Hey everyone, it's Mr. Derek here. This is going to be one of the first videos we've done. This is a reverse engineering and function analysis PowerPoint that I want to walk you guys through. It'll help you with your week 3 assignment. Based off of the survey results that you guys had posted, an overwhelming majority had said that they actually did want to have a video to go along with the PowerPoint with the assignment, so here we are doing one. So we're going to start off first. This is reverse engineering. So you guys have done a visual analysis. In visual analysis, you guys will have either done a spray bottle, or you guys might have done like a dial pump dispenser of soap. And what a visual analysis is it really takes apart the product based off of how it looks. So in reverse engineering, there are three stages. There's a visual analysis, there's a functional analysis, and then there's a structural analysis. The visual analysis is the first one, and that talks about all the principles of design, like the contrasting colors, the hue, that sort of thing. Uh, Going from a visual analysis where you really just look at the product from afar, you don't really touch it, you don't play around with it at all. It's really just what does the object look like. You then go to a functional analysis. What a functional analysis is, if we go through the PowerPoint here, well, first let me kind of back up here. What is reverse engineering? It's the process of taking something apart, analyzing its workings in detail, usually with the intention of understanding its structure, function, and operation. So this is where we're at right now. We've understood like how the product looks. Now we want to see how it operates or how it functions. So why do we do reverse engineering? It's really for documentation. If there's no existing documentation of a product, you got to start somewhere where you got to take it apart, figure out how it works, record all your data. Interoperability, what that means is if you want it to work with another existing product. So if it's, say, like you have a company that has a product and you want it to sorry with that. You want that product to work with the other products that you have in its line. You might want to figure out how that works. So you take it apart and you're like, how is this going to work with our product line? Or it might be maintenance. What if it's like a really, really old product, like say something from the 1950s or 60s? You want to take that apart and figure out how to get it to work again. This happens a lot actually. If you buy something on Craigslist, or think of it like a car, right? Buy an old car and you want to get it running, you don't have to take it apart. And in taking it apart, what you do is you actually figure out how it works. You get a better understanding, like a grasp of as to like what that product or what that car or how it was built. Sometimes we use it for discovery. Sometimes we're just really curious. This is actually really important right now with this whole situation we're going through. Academic research and learning and curiosity. We use reverse engineering, not we, but scientists use reverse engineering a lot in the medical field. What they'll do is they'll take something and they'll reverse engineer that, whether it's body part for like a prosthetic, or they'll take that the human brain apart to figure out how it works. They do autopsies, right? That's a form of reverse engineering in some sense. And then you have like military and commercial intelligence, and this is actually kind of a cool one. So militaries, other governments, they use reverse engineering a ton, and the reason why they use that is to take apart like spy planes or any kind of military equipment that might have been like stolen or lost. Like the B-29 bomber was actually destroyed in Russia during the Cold War, and the Russians actually rebuilt it. And then they were looking at I think that was the Stratocaster, I'm not, or the Stratofortress. They actually took apart that B-29 and they reverse engineered it, and they built their own version of a long-range bomber. The RQ-170 right there, if I'm not mistaken, that was Iranian. That was actually a pilotless drone that we were using to spy over Iran. It had crashed, and the Iranians actually took it apart, rebuilt it completely, and it's almost a spitting image. So military and commercial intelligence absolutely use reverse engineering all the time. Sometimes during investigations, so analysis and testing, document panting or infringement, and forensics. Say like a bridge collapses, what you'd want to do is you'd want to take all those parts from the bridge when it collapsed and figure out, okay, what happened here? Like what part of the product failed? That's used in a ton of engineering aspects. Document patent infringement. Thinking back to the Apple and the Samsung glass debate, like who was the first one to use the Gorilla Glass? Going back to the engineering notebooks, before they even went to court, they actually analyzed the glass. They would take it apart, do a chemical analysis of it, and they wanted to make sure like this is actually the glass that we use. Okay, now we have a case. So that's used in investigation all the time too. Where you see it a lot though is an improvement or redesign of a product. So an invention is something that's brand new. An innovation is something that's been redesigned and improved. You can increase efficiency, you can improve reliability, you can improve manufacturing techniques, eliminate failure mode, reduce cost, increase ease of use, reduce negative environmental impacts. You can recycle parts, and there's various other reasons too, but it's really improving or redesigning a product. Think of like when the new iPhone comes out. What do? They look at the old iPhone and they take it apart and they say, okay, what worked well with this iPhone? This part tended to fail. If you dropped your phone on the corner, maybe it was the digitizer that broke. So we're going to move the digitizer in so that if someone drops their phone, it'll survive a higher impact. The glass tends to shatter, so we're going to use a different type of glass. The speaker wasn't that great, we're going to add a different kind of speaker. In order to do that, you actually have to take the old phone apart, and that's really reverse engineering right there. So what kind of tools do we use? If we were in the classroom, we'd have access to a lot of these micrometers or micrometers. We use digital or dial calipers right here. Optical probes, these are actually kind of cool. I've been to many companies right now. I think I've been to like 4 or 5 that I've seen this actually in use. And this is the quality control departments usually have these. It's a ruby tipped. This is actually a ruby tipped probe right here. And what it does, it actually goes over and it touches side to side and measures these parts down to sometimes up to like a 10,000th of an inch. Medical imaging, if you ever had an MRI, that's a perfect way to reverse engineer like the human body. And 3D held laser scanners. These are actually very, very cool. What they do is they shoot off little beams. If you ever had an Xbox Kinect, there's companies that have actually taken the Xbox Kinect and it shoots a little infrared light off at parts and it detects like what the object is. All these little points right here in that visual analysis, what they actually talked about in points, these are the points that the computer will use to generate this object right here in 3D using these little beams of lasers that shoot off of it, and it recreates it in 3D. It's very, very cool technology. So as I said before, there's 3 stages of reverse engineering. You have visual, functional, and structural analysis. In this one in particular, we're going to be worrying about the functional analysis. So this is after the product has been selected, and this is a non-destructive functional analysis. The first purpose of all of this is to figure out what is the product's purpose. So what does this product, what is it supposed to do? If we use the example of like a spray bottle, I look at the spray bottle, say I have a yellow handled spray bottle, and when I look at it, it's clear, there's liquid inside, there's like a little tube that goes down it, there's some sort of spring apparatus. I haven't touched it yet. So what I need to do now is during my functional analysis is figure out what is the purpose of this. So I'm going to assume, right, that if I squeeze on that trigger, it's going to spray something out. It's like a pump. So in this functional analysis, I'm going to try it out actually. So these observations are made to determine how the product functions. These observations are recorded in detail. So we talk about like inputs and outputs. So if I were to pull on the trigger of the spray bottle, what happens? Well, sprays out from the nozzle. That would be an input of me pulling the trigger and pressing down that spring, and output would be that fluid to suck out of the tube and spray out the nozzle tip. Here's a really good example here. So this is a toothbrush, and this is an electric toothbrush. And I actually think I had something very similar to this when I was in high school. This is an older PowerPoint. The purpose of a toothbrush is to clean teeth and gums and to prevent tooth and gum decay. Water and a cleansing paste are used in conjunction with the brush. So that would be the purpose of a toothbrush. Okay, the core purpose in a very technical worded way. And then what we do is we do an annotated sketch. This is part of that visual analysis right here. An annotated sketch, this is a very, very good example right here. They sketched the product and they annotated, and what annotations are, the little subnotes that go off on the sketch that tell you like what each part is. Here's the head, it rotates, because I can't see this, I'm not going to have the object in front of me, I need this sketch to be very, very detailed, right? So a secure neck, there's grips for the human hand, this toggles the electricity, here it stores electricity, maybe there's a battery underneath here, there's components inside that I can't see, right? It converts electricity to torque, torque being rotational force. So this is a hypothesis, and we devised that to describe in detail the sequential or order of operations or the function of the device using a sketch. And then we get into something here. It's called a black box system model. So the black box system model is used to identify what goes into and out of the product in order to make it work. So if I have inputs, a product function, and outputs, let's see if I go forward here. Inputs for the toothbrush, the hand motion, so moving the toothbrush back and forth in your mouth to scrub your teeth, that would be an input. The toothpaste is an input. Water, and of course energy if it's battery powered. And then inside this product function black box, things happen that we don't know yet, right? We know we put the inputs and we see outputs, but inside is the function that kind of takes place. The output are here for a toothbrush. You have sound, right? It buzzes, heat, maybe the battery gets a little warm as the motor starts moving. You get waste, because obviously you're going to have toothpaste and all that nasty gunk inside of your mouth. But also one of the outputs is clean teeth and gums. And that would be the intended result. So inputs, the product functions, and then you have your output. And that brings us to the end of the PowerPoint. So what I want you guys to do, definitely look through this PowerPoint. There's 1, 2, 3, let's see. There's 16 slides. You can go through this video many times if you'd like to, but I'm here to help you guys. If you have any questions, please reach out to me, and we look forward to talk to you guys. Thanks.